Okay, let's just take this back to the beginning. Just go back to the beginning. There's our equation. We want to find the optimal or the extreme value, right? So we take the derivative with respect to x, we get 36 minus 6x, and then we force that to be equal to 0, because that slope is 0, gives us the extreme values, either the max or the min. Okay? So that implies that x equals 6. All right, so now we have x equals 6. That's our max or our min. Now we go take the second derivative, which could be, you could do that, you could do xx. We like xx actually in this context. But now we're going to say that equals minus 6. Right? That. The 36 is going to be 0. We get minus 6. That's less than 0. Therefore, we have a maximum. Okay? And we're done. We're done? All right. All right. Two variables. Y squared minus 43x minus 23y. Okay, so the partial of that with respect to x is going to be 8x plus y minus 43, and we're going to set that equal to 0. And the partial of z with respect to y is going to be x plus 6y minus 23 equals 0. And if we solve that, I'm pretty sure we get x equals 5 and y equals 3 as our optimal point, maximum point. Now we need to take this and turn it into a Hessian. Yes? So we can find the second derivatives, right? Second derivative with respect to x is going to be 8. Second derivative with respect to y is going to be 6. Okay? We do the cross partials. Okay? And in each case, that cross partial is just going to be 1. So we're going to have a Hessian. And our Hessian is going to be, again, fxx, fxy, fyx, fyy, which is 8, 6, 1, and 1, which is 48 minus 1 is 47. And what do I have? Okay? I have the first principal minor here, which is fx, is a plus, right? fxx and fyy are both greater than 0. And I meet my other part of this condition by saying this is positive, or by saying that the two second derivatives multiplied together are larger than the two cross partials modified together. But we can do it by saying there are these two, in this Hessian, we have these two principal minors, and we have, right, the determinants of both of those minors. So there's the first minor is just fxx, and the determinant of that is fxx, and then the second one. So they are both positive. The second order conditions, are such that both of these things are positives. Okay? Which means what? It means we have minimized the function at that point of 5 and 3. So 5 and 3 is the minimum value of this function. Okay? Okie dokie dokie. Dokie. All right? So how about this now? Okay, beautiful. Yeah, you know where we're going and you're thrilled. So I got to find the partial of this with respect to x, which would be 20x minus 20y minus z. Set that equal to 0. The partial with respect to y would be minus 60y. Oh, that's a plus, sorry. Plus 60y. Yeah. Minus 20x minus 30z equals 0. And the partial with respect to z would be 2z minus 30y minus x equals 0. Okay, fun? And then we can solve all that. Solve all that. Solve all that. And we don't really care. What we care about is what? Yeah. fxx is going to be what? It's going to be 20. fyy is going to be 60. fzz is going to be 2. They're all positive, right? And we're going to create a Hessian, a big Hessian, right? And the Hessian's going to be fxx, fxy, fxz, fyx, fyy, fyz, and fzx, fyz, and fzz. Okay? So we're going to have a 20 and a 60 and a 2. Yes? fxy is minus 20. fxz is minus 1. fyx is minus 20. What a shock there. This should be symmetric, right? This matrix should be symmetric. fyz is minus 30. fzy is minus 30. And fzx is minus 1. And look. Actually, I screwed that up, right? That's minus 1 and that's minus 30. And it's a beautiful symmetrical matrix. Okay? Within this matrix now we have 3 principal minors. So we have H1 is just 20. We have H2, which is 20 minus 20, 60 minus 20 is 1200 minus plus 400 is minus 1200. 1200 minus 400 is 800. That's a minus sign. Is 800. That's 20, which is greater than 0. That's 800, which is greater than 0. Well, and then I have the whole thing, right? Which you can either call H3 or you can just call H because it's the Hessian of the whole thing, right? And it's this thing. Right? So the determinant of that is 20 times that minus negative 20 minus a minus 20 times minus 20 minus 30, 1 and 2, plus 1 times minus 26, 1 minus 30, right? And we can solve all that, and it's miserable, right? That's 20 times 12 minus 900 plus 20, because 2 minuses, right? It's a plus. Minus 40 minus a negative 30, right? That would be like plus 30 plus 1 times 600 minus 6, right? And so this is going to be some huge, nasty negative number, unless I did this wrong somehow, which I might have done. But we're going to work this all out. That's, minus 200. That's plus 500 and something. That's like minus 1400. Yeah. And it works out to be something stupid. But we're just like really happy about that. Okay. So what if we have, something that looks like this? Okay. And we just want to optimize it. Well, we're going to find the first partials, right? And there's 3 of them. Yes? So that's 4x minus 2y minus 3z equals 0. Then we get 6y minus 2x minus z equals 0. And we get 8z minus 3x minus y equals 0. And, you can go ahead and solve that if you're really, interested in it. But instead, let's move on now and find fxx, fyy, fzz. Well, that's going to be 4, 6, and 8. Is that clever? Okay. All of those are positive. All right. So this could be that we'll find a minimum, but ignoring that. And it's actually likely, looking at all this, that everything's equal to 0, but forget that. We can find, what we want to do is build a Hessian. So we're going to take this now, and we're going to draw a Hessian. And these 3 numbers are going to be the principal diagonal of that Hessian. So the Hessian's going to be 4, 6, and 8, and then some other stuff. Remember, we get fxx, fxy, fxz, fyx, fyy, fyz, yes? fzx, fzy, fzz. And that's the Hessian. Okay? So xy is minus 2. xz is minus 3. So we're going to have a minus 2 and a minus 3. fyx is minus 2. fyz is minus 1. Okay, and we actually know how this is all going to work out because they have to be equal things, right? So zx is minus 3, and zy is minus 1. So we have a minus 3 and a minus 1. And we're pretty sure it's right because this thing has to be symmetric, right? This Hessian. Okay? Within this Hessian, we have 3, count them, 3 principal minors, yes? We have that one, We have that one, and then we have the whole thing, which is still a principal minor even though it's the whole thing. So H1 is going to be 4. That's greater than 0. H2 is going to be 4 times 6 minus 2 times minus 2 is 20, right? 24 minus 4 is 20. That's greater than 0. So far, all is well. And then we need to find the determinant of this whole thing. So we've got 4, 2, minus 3, 2, minus 3, 6, 8. And those are both minus 1s, right? So that's going to be 4 times 6 minus 1 minus 1, 8. Minus 2 times 2 minus 3 minus 1, 8. Plus 3 times 2, 6 minus 3 minus 1. Okay? That's 4 times, what? 48 minus 1 is 4 times 47. Minus 2 times that 16 minus 4 is 12. 16 minus 3, rather. So that's 13, right? Plus 3 times minus 2 minus 18 is minus 20. And we can do the math, and you can do that if you feel like, but this is going to be greater than 0. So what we've got is that H1 is greater than 0, H2 is greater than 0, H3 is greater than 0. That means this matrix is positive definite, and our solution is a minimum. Good? It's exciting. It is. It's very exciting.